and vocab. Okay. Change my view here. See what that does. Okay. Matrix operations and vocab. 6.1 itself, if you look in the book, doesn't start with this. It starts a little bit further along in matrices than we are right now. It assumes that you already know some stuff about matrices. And so we're going to go over that stuff that you would need to know before we actually jump into what's formally 6.1. But we're going to call this 6.1 for now. Okay, so first of all, what is a matrix? It's an array of numbers, pretty much. So let's see, matrix. An array of numbers. And it's a pretty organized array. It's basically a way of organizing groups of numbers and things like that. A lot of times they're used to represent equations and stuff like that, which we'll see later. You can use these to solve equations, to solve systems of equations, which is the practical thing that we're going to be using them for. But first we need to know a little bit about what they look like. So matrices have rows and columns. And so the way that we kind of identify a matrix or a piece of information about a matrix is its dimensions. How many rows, how many columns does it have? So if I have a matrix that looks like this, matrices are in brackets. So I might have, 1, 2, 3, 4, 5, 6, and this is my matrix. So that's an example of one. The dimensions of the matrix would be how many rows it is by how many columns it is. So it's rows by columns. And if you have a hard time remembering what's a row and what's a column, remember if you have like columns in architecture or on a house, those are always straight up and down. So the columns are straight up and down. The rows are sideways. So this matrix has 3 rows and 2 columns. So it would be a 3 by 2 matrix. So that would be the dimensions of this matrix. So that's one of the most important things about a matrix so far. Being able to identify how many rows and columns it has. You can also call out a specific number in a matrix. So the numbers in a matrix are called elements. Okay. And oftentimes matrices are given a name, like we could call this matrix A. We could say A equals this. So I'm going to refer to this matrix as A when we talk about the parts of it. So A's dimensions are 3 by 2. It has elements, which are numbers in the matrix. So if I wanted to know how many elements matrix A has, that would just be how many numbers are in this matrix. So that would be 6. And sometimes you'll see the matrix A referred to as A in brackets. Sometimes you'll just see it referred to as the capital letter A. They both mean the same thing. We could say something like A has 6 elements, because there are 6 numbers in it. Okay. We could also call out a specific element. So if I said something like lowercase a 2, 1 as like a little subscript. That means the element in matrix A that's in the second row and the first column. So I would go up here and I would go, okay, the second row is this middle one. The first column is number 3, or corresponds to this column. So 3 would be the element that is in the second row, first column. So that's how I would call out that specific one. If I wanted to call out, let's see, we could go 1, 2. Then that would be the first row, second column. So first row is the top row, the second column is this one, so that element would be 2.
Kyle Jones, please call 723290. Kyle Jones, 723290.
It's almost like regular school. We get announcements. Okay, so on your own real quick, what is element, we'll go with 3, 1. Go ahead and try that on your own really quick. Which number is 3, 1? Once you think you got it, type it in the chat. Nice. All right, looks like we got it. Yes, it is 5 because it's the third row, second column. Or first column, sorry. All right. So that's how we would label elements in a matrix. There's a bunch of different matrix vocab words that describe specific types of matrices. So we're going to go through some of those as well. Okay, the first one we're going to go over is something called a square matrix. All right, a square matrix, not a real creative name. It's just a matrix that has the same number of rows as it has columns. So for example, if I had a 2 by 2 matrix, that would be a square matrix. Or a 3 by 3. Or a 4 by 4, or a 25 by 25. Oh, thank you, Jasmine. There we go. So same number of rows and columns in a square matrix. 2 by 2, 3 by 3, 25 by 25, a million by a million. That would be a square matrix. Okay. So that's a square matrix. And then there's a special type of square matrix called the identity matrix. An identity matrix is a square matrix that has 1s on the diagonal and 0s everywhere else. And it's on the main diagonal. We're going to talk about that as well. Okay, so if I have a 3 by 3 matrix, the identity matrix has 1s across this diagonal, and it has 0s in all of the other places. And you can do this with any matrix. If you had a 2 by 2, or with any square matrix, that would be the 2 by 2 identity matrix. This would be the 3 by 3 identity matrix. The 4 by 4 would have 1s along the diagonal and 0s everywhere else as well. This diagonal here is the main diagonal. Of a matrix. Okay, so the diagonal going from the top left to the bottom right is always called the main diagonal, and we will refer to that a lot. Usually it's to mention that there's 1s along it or something like that. And it's called the identity matrix because if you multiply a matrix by the identity matrix, you get that same matrix back. Okay. Let's see, there's a few other special types of matrices that we're going to call out. Move a few things here so we have more room. Okay. So there's something called a row matrix, which is just a matrix that is made of a row only. So like if I had 1, 2, 3, 4 as just a row, that would be a row matrix. A matrix with just one row. And then likewise, a column matrix is a matrix with just one column. Okay. So those are pretty much the main matrix vocab things that we need to talk about for today. We also now are going to move into some basic matrix operations, like adding and subtracting, and if we have time, multiplying by a scalar. Okay, so moving things up. Adding and subtracting matrices. Okay, so first of all, you cannot subtract and add just any matrices with one another. They need to have the same dimensions. So you can only add and subtract matrices with the same dimensions. So that's very important. You can only add and subtract them with the same dimensions. So that means if your matrices are both 2 by 2s or both 3 by 4s or whatever, you can add and subtract them. If they are not, then you can't, and it's considered undefined. Okay. So let's say I have a matrix T, and we'll say it has 1, 2, 3, 4, just like that, and a matrix U, and U is going to be 7, 8, 9, 10 for its elements. Okay, so if I wanted to do T plus U, first I would have to double check. Do they have the same dimensions? Well, T is a 2 by 2 matrix. U is also a 2 by 2 matrix. So we're good to go. The next thing you want to do is you basically are just matching up elements that go together. So if this is the top right corner or top left corner element, it goes with the top left corner right here. So we would go 1 plus 7, and that would become your new top left corner element. Then we'd have 2 and 8 go together, so we go 2 plus 8. 3 and 9 go together, so we go 3 plus 9. And then 4 and 10 go together, so 4 plus 10. And then we would just rewrite it as 1 and 7 is 8, 2 and 8 is 10, 3 and 9 is 12, and 4 and 10 is 14. So this would be our answer for what is T plus U. Okay. And oh, the name of the new matrix, it would just be called out as T plus U. You could name it something else if you wanted to, like if you wanted to use it later in a further step of work. If you didn't want to go around calling it T plus U all the time, you could rename it, but typically we would just call it T plus U. Okay. You can also subtract. Let's go U minus T this time. And you would do it in very much the same fashion. You would take the top left corner here in U, and you would subtract the 1 from T. So you'd go 7 minus 1. Then we'd go 8 minus 2 for the next one. 9 minus 3. 10 minus 4. So we would get 6, 6, 6, and 6. That's kind of fun. Didn't plan that, by the way. Okay, so we can do addition, we can do subtraction. If I had two matrices, like let's call this matrix A is 2, 3, 1, 7, 9, 8, and B is 2, 1, 9, 6, 5, 10. With this new one, could I do A plus B? What do we think? Type it in the chat. Could I do A plus B? Okay, cool. No, we cannot, because they're different dimensions. We have a 3 by 2 and we have a 2 by 3. So we cannot add those, unfortunately. So we would just say undefined. That's one type of problem that you'll see today. You'll be asked to either do the addition or subtraction or say that it's undefined. Okay. The last thing that we're going to do for today is multiply by a scalar. And to do that, I'm going to flip this paper over. Okay, so multiplying by a scalar just means taking a matrix and multiplying it by any number. So for example, if I had something like this, so this is my scalar, this is my matrix. What this would end up looking like is giving the 3, multiplying it by every single element in that matrix. So we would just end up with 3 times 1, 3 times 2, 3 times 3, 3 times 4 for our new matrix. So 3, 6, 9, 12. Okay. So hopefully that one is probably the easiest one of all. It's just like the distributive property. Just giving that number to all of the others. Okay, are there any questions up to this point? Anything we're not sure about so far or that we'd like to go back to real quick? Okay. Yeah, the only thing with doing answer in the chat with matrices is that it makes it a little bit, well, you can't really type a matrix very easily into the chat. So I think what we're going to do is go over to the assignment, get a little bit of practice, and then come back together, and we'll see how that goes. Okay, so today's practice. Stop recording.